Well, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here. Great to see some new faces and also some recognizable faces. By show of hands, who's here for the first time, or not since your fourth grade field trip? All right. All right, well, good. Who here remembers? All right, a good portion of the other. That's great. Actually, what I do like to point out that the people who raise their hands second have a valuable piece of information. Kopernik, we're a nonprofit organization, but we belong to what's called the ASTC, the Association of Science and Technology Centers. And your Kopernik membership gets you into Kopernik, but it also, through the ASTC, gets you into over 380 other science centers. So if you like this kind of place, a Kopernik membership is actually quite reasonable. In fact, a number of years ago, my daughter, Catherine, and I went down to the Franklin Museum down in Philadelphia. And had we had to pay the regular day, the one-day charge for just one adult and one child, it was actually more than the family membership for 1 year. So it's certainly worth investigating. So let me just go here. We'll get out of this mode here and go to just a very quick review. Our website keeps you really up to date with what's going on. We always post, so like tonight's program on basic telescopes, you can learn about that. But other things that are going on, like right now we're in the process of just about launching out, well, in about 3 weeks we'll be starting our summer camps, STEM-themed summer camps, so you can learn about that. These are camps for students that are going into second grade through high school, and they're week-long summer camps. This is our 33rd year of offering summer camps. We even offer a program called Kopernik Kids for kids that are 3 to 6 years old, and it's a once-a-month kind of program where we have kids learn to look at the world through the eyes of a scientist or an engineer, but at a 3-year-old level. And they have a great time. You can always go to our calendar, to our classes, program, and events, and so public programs. You can learn about what's coming up. So actually, last week we had a talk on the planet, the history of Planet X. This week it's basic telescopes. Next week it'll actually be summer skies. And then finally, something we do every year, it's called the Great Telescope Dust-Off. So for those people with telescopes that are either sitting in the garage or attic, and you haven't used them in years, bring all those parts up, and we'll help you put them together and show you how to use them. Then later on in the summer, we've got lined up a couple of talks. One is actually talking about the pretty precipitous decline in butterfly population. And talk about what's going on there and how we might try to reverse that trend. Also, we have a professor from Binghamton University who has done a lot of work out at Easter Island. And if you recall, Easter Island is that place that has those big, large Moen, those big Easter Island, rock heads that are just many tons of weight, and they weren't carved where they sit. They were actually carved elsewhere in the island, and hundreds, if not thousands of years ago, those people that lived there found a way to actually move them and plant them where they are. So it'd be great to have Professor Lippo back for that. So there's always something new coming on here. And this is actually one of the things I love about Kopernik, is an opportunity to learn something new. Again, not everything we do here is about astronomy. We've had a talk about the physics of music. Why does a violin, an oboe, and a trumpet all sound different playing the same note? So it's an opportunity to just expand your mind, and of course, what we always like to do is at the end of the program, if it's clear, invite you to look through the telescopes. And unfortunately, tonight is not your night. But what we do though is, if you paid to get in, we will give you a card to come back, a complimentary card to come back on another night. That's hopefully clear. We do run other programs from time to time. Like in August will be the Perseid meteor shower. So we'll be open on those nights for when clear. one of the things also that we do is that we do all of our Friday night programs on our YouTube channel. And this actually sort of started because of COVID. As one of the few things that COVID did positively for us. It actually got us to start having our, initially we had our speakers Zoom into us and we would put it out on a YouTube channel. Now we have over 13,000, actually close to 14,000 subscribers. So if you go to YouTube and you type in Kopernik Observatory and Science Center, you can subscribe to our channel, but you don't have to in order to watch it. But what's also nice is that all of our programs are actually are kept on YouTube. So a few weeks ago, we had somebody talk about the Galapagos Islands. We had some robotics teams up and talking about their competition robots. We've had talks about AI, and we've had a science and religion talk. On Pi Day, on March 14th, 3.314, we had a talk about a game of paradox and the most irrational number. So there's always a great material to look at. We got 5 years worth of these on here, but we also do a number of when there's a particular astronomical event going on, like perhaps a lunar eclipse. We will be doing a program for that. In fact, actually, Jenny Cardy is who's running our live stream tonight, is our live stream astronomer. And so she was actually, this past lunar eclipse that started at 2 a.m., Jenny was here for, and basically did 5 hours worth of coverage. But what she did then is to do a very quick 1 minute time lapse of the lunar eclipse in March. So let's run that. Now this, you'll start to see the umbra starting to cover the moon. Eventually you'll see Jenny will have to change the exposure right there so that we start to see more focused on the eclipsed side of the portion of the moon. And this was all done with a C-star, a telescope which you'll learn about a little bit later. And eventually the Earth finally starts to move again, and actually the moon moves in this case, and so we then changes the exposure back to sort of a standard view. So what's nice about this these live streams is that again we're running our live stream tonight, and we have literally people from around the world. Usually, very often, a woman, Lindsay, who lives in Adelaide, Australia, is basically finishing her breakfast and is watching us live. So, well, again, we're very fortunate to have a very dedicated group of astronomy buffs around here. The Kopernik Astronomical Society is the astronomy club that is resident here at Kopernik. And one of its members, longtime members, and he's also one of Kopernik's educators and also sits on our board and gets no sleep whatsoever, is Art Cacciola. And he has agreed to do a talk on getting you started with your first telescope. So Art, we'll turn your mic on and we'll go from here. Well, actually, we'll put your presentation up.
Thank you, Drew. All right. Welcome, everyone. Thank you for attending. So this is a very basic class, but I hope to give a lot of information, a little bit about a lot. And we'll be happy to answer questions to give you more details as we need. So there are a couple of questions you need to ask yourself before you consider buying a telescope. And the ones I think about most are, what do you want to look at? Okay? Like when you buy a vehicle, do you want to buy a van? Do you want to buy a sports car? You want to buy a motorcycle? You need a school bus? You know, what do you want to observe? and how much you're willing to spend. Not how much money do you have, how much money are you willing to part with to do this. And the third thing is portability important, is being able to move it. I know a couple of people that have 14-inch telescopes similar to the C14 we have in the dome on the right. And I know those guys pick up that scope and put it on the mount. I could never do that. I had a couple of friends, one who sold it just about a month or two ago. Another one is selling it right now. They have this 11-inch telescope. And they're offering it's a very nice scope, and it was a very attractive price because it was used but in very excellent condition. And I thought, do I want to buy that? I have a 9 1/4, so that's an 8. I have the size, next size bigger. And then as I was struggling putting my 9 1/4 on in the dark, you know, on the mount, I realized, nope, I'm not going to buy an 11-inch. So you got to think about what's realistic. Now, if you have an observatory, you could buy a big scope and plunk it down and leave it there, and it's great, okay? But if you don't, you might want to consider that. And portability, so when my daughter first got into astronomy, I wanted to buy her a Dob, an 8-inch Dob, which we'll talk about, but she had a little Honda Civic. It just wasn't going to fit too well, so I ended up buying her one it's called the truss tube, and the truss, it actually collapses down to a small size so you can just throw it in the back seat. So all those things are important to consider. And one other thing is, do you want to do astrophotography? And we'll talk more about that in a few minutes. Drove all those miles and they're closed. Oh, that's never happened. All right. So you want to buy the largest aperture diameter that you can afford or you're willing to spend. Why? And also that you could physically handle, like I just told you about, and that you can store. That's something else. I can't tell you how many people I really know who have their telescope sitting in the dining room. Okay? No, I'm not kidding. It's true. So you have to have a place to store it. I'm not saying that's a bad thing to do, but not everybody's going to be able to do that. So the larger the aperture, the larger the diameter of the mirror, or the larger the diameter of the lens, okay, the better you are, okay? It gathers more light, and you can see dimmer, more faint objects, things that are very hard to see. They'll come up in a bigger scope. You'll see them much more easily. And also, if you have good optics, you'll have better resolution. Everything will be sharper and clearer if you have a bigger to start with. And there are trade-offs. There are always trade-offs in life. Aperture versus price versus portability. So the larger the aperture, the more expensive and less portable, and all the variations in between. So you've got to think about all those things before you go off. Talking about the price. So I'll give you an example when I bought my canoe or when I bought my kayaks. You pay so much for the canoe or the kayak. Okay, that's good. But then I had to buy oars or paddles. Then I had to buy life preservers. And I had to buy a roof carrier. And I had to buy the thing to hold it on the roof carrier. And I had to buy all the other things, you know, the whistle and all the extra things I needed. And it all adds up. So they call that going down the rabbit hole. I'm sure you've heard that expression, and it's very easy to do in astronomy. So power, oftentimes you'll read in an ad for a scope like this, it'll say 454 power, and you go, wow, you know, you can see 454 times, you know, that's great. But then you look at it, it's really blurry, and it's terrible, okay? So don't worry about power, because power is adjustable by changing the eyepiece, okay? And we'll talk about that also. So remember that a small scope with high quality optics can give you super views, okay? So you don't have to have a big scope. A quality scope sometimes is better than a bigger scope. All right. So get familiar with your telescope. Learn what each knob does, and more importantly, be able to find it in the dark. I know what this knob and this knob does, but sometimes I have locks on this. Where though? There's one lock here, and the other lock's here. Okay, now I could do this stuff. But in the dark, I don't see that stuff. So you have to know where it is. I have a scope just like this and a mount just like that, so it's easy for me, but it's not if you don't know. Don't over-tighten stuff. A lot of the stuff is plastic with steel gears, steel screws. You over-tighten it, you're going to strip it, you're going to break it. Just snug, okay? Just snug. It's not your lifeline there. Move the scope with the locks off, so I just locked it. So I try not to move it. I try to unlock it before I move it. I have the wrong axis. It's okay? So do that. And keep the optics clean as best you can. Try to keep the dust off it. That means put the cover, so there's a dust cover on the plate up here, okay? Keep that on. My scope, I throw a plastic bag over it, a garbage bag, or a special cover that helps keep the dust off it, keep it clean. You can clean the optics. Dave Daniels there is an expert on that. But it's not easy. You have to be very gentle. You have to, what the formula is, really, it's like distilled water, so you have nothing else, no minerals in it, and a couple of drops of Dawn, and then use a whole bunch of cotton swabs, and you clean it from the center to the outside, keep throwing the cotton away. Then at the end, you just rinse it off with distilled water and let it air dry, or you could try to blow it off. But it's easier to keep it clean than it is to clean. All right, eyepieces and magnification. So eyepieces come basically in two sizes. They're really about 4 sizes, but I'm going to talk about the two. Well, I'll tell you about the third one, I guess. There's the 1.25" right here. Okay, that eyepiece will fit on this telescope, and this eyepiece will fit on that telescope, and actually fit on this telescope because they have an adapter that goes in there. So you don't need, if you have more than one telescope, you don't have to have a whole set of eyepieces for each telescope. Okay. The other size we have are the 2-inch. That's the other common size. Just dropped my mic. Oh, I guess I did. This is the other common size, the 2-inch barrel. This is preferred when you get serious because it's bigger. Your eye gets more light, gives you better aperture, but it's more expensive. But eyepieces last pretty much forever, unless you throw them on the ground when you get mad. They'll last a long, longer than you will probably. The other size I was going to tell you about is some scopes have a smaller eyepiece called a .96, I think. It's a little smaller than the 1.25". It's close to almost an inch. Some of them are very high quality, but a lot of them are plastic lenses, and they're pretty cheap. Okay, so you may start out with that in the beginning, but it's not. You might want to get a better eyepiece, and they have some bigger eyepieces as well if you have a nice, expensive scope. So the magnification. So let's say all right, I'm just going to make it simple. Let's say I have a scope with a light path, a focal length of 100 millimeters, okay? Just saying that, okay? If I put a 10 millimeter eyepiece in that 100 millimeter focal length is the length from the lens to where it comes out, okay, to where it focuses. On this scope here, it goes down to the bottom and then back up and out. So it would be this plus that. But it has a focal length, and it's written on the scope, okay, what it is. So you take that, and if I had a 10 millimeter lens, I would divide the 100 millimeters by 10 and end up with the number 10, so the power would be 10 times, okay? It's pretty simple to figure that out. So I recommend, so this actually this advice came from Al Nagler. who runs Teleview eyepiece telescopes. He's world famously known. He sells eyepieces, and he'll tell you you only need 2, maybe 3 eyepieces. You don't have to have a whole set of 15 eyepieces. You know, 2 or 3, if you figure it out right, that's all you need. So I recommend the same, 2 or 3. So for example, you might have a 17 for like a medium power and a 10 millimeter for a little higher power, and then possibly a third one. I like a wider angle so I can see more at one time, especially when I'm looking for something. Finding it first, I can see more of the sky. And then I go into higher magnification. Or if I'm looking at a planet or the moon, I may want higher magnification to see up close on those things. So that's that. So it's a little backwards in thinking, but the lower the number in millimeters, the more magnification. Okay? So a 10 millimeter has more magnification than a 17 millimeter eyepiece. And I already told you the eyepieces come 1.25 inches and 2. Now there's another device called the Barlow. It's a lens. It looks kind of like an eyepiece, but really is a tube with a little lens on the bottom where an eyepiece sits inside it. I should have grabbed one to show you, but it's pretty simple. And what that does, so if you have a 2-time Barlow, okay, it will have the eyepiece in millimeters. So a 2-time will have. That means if I have a 25 millimeter eyepiece and I put the Barlow on, I end up now with the 12.5 millimeter eyepiece. So it's twice as powerful. All right. And so that device, in effect, can double your set of eyepieces. It might be something to consider. You might not want to get a 10 and a 20. You might want to get something a little bigger or smaller than a 10, or a little bigger or smaller than a 20, so that it doesn't just duplicate. All right. Finder scopes. So this is a finder scope. It's really like a mini telescope. Okay. If I try to find something in this, I'm not going to know what I'm looking at. I see a whole bunch of stars. They look bright. I don't know where I am. I use a low power finder scope. This is a 6 times power, and I could see now a bigger area of the sky, and I know what I'm actually looking at. This has a bracket for the finder scope, and this does too, but they're not currently on. But a finder scope is something I would recommend. It's difficult to point a scope without a finder. One like this isn't terrible because I actually sight down the tube and I look at the things like that, and I could do it pretty well. But you get a design like this or that, and without a finder, it's going to be much harder to sight. So it's a low power scope, wide field of view, and it's set up parallel to the telescope. Some of them have crosshairs, and some of them have illuminated like a red dot or a little target inside. That's pretty good. So up on top here, you have 2 examples of some little higher quality finder scopes. And this is what you call a telrad. So this is probably a 6 and an 8 times power finder scope. But this telrad is 1 power. That means there's no magnification. I really like those 1 power finders, because when I'm looking for something in the sky, I could just move the scope and look through that thing, and I just can move the scope until my center dot or my bullseye is right on the object. Okay? We have another example of those. So we have the different brands. This is the Teleview Quick Point. It's got a little laser in there and just kind of points to it. These are similar to the ones we just looked at, although this one has an illuminated radical in it that it would light it up. This is another kind of like might have on a gun. And this is a Rigel, another similar to the Telrad. So these are all different tools. Simple scopes, things like these are good. Those are also excellent as well. Now, it's important you align your finder with your telescope. So what that means is I point this at something. Where do I want to point it? Let me move it this way. All right. Now I'm in the daytime, so I got this on the top of a flagpole on the ball. Okay. So I lock it down so it doesn't move. Now I get in the eyepiece here, and I look for it, and I don't see it. So I move it around a little bit, and I finally see the pole, and I move it up and down so I get it right in the center. The ball is right in the center of this. I lock it down. Now I get the finder scope, and it has 3 knobs, usually 2 or 3 knobs, and I adjust them so that that ball is in the center of the crosshairs in this. If I do that in the daytime, at night, when I'm looking for something, if I get it in here, I'll have it in there. Okay? If you wait till nighttime, you won't see that flagpole. You'll see a bunch of stars, but the stars pretty much all look the same. Even if you think, oh, that's a bright star, that must be it. There are a lot of stars look bright in that. So get it done in the daytime. Now that's something you almost need to do, not every time, but almost every time you move it. You put it in your car, took it home, put it in the closet, whatever, it gets banged. So you just have to tweak it a little bit. Okay, it shouldn't take you that long. And when you do it, it's trial and error. You're trying to move it, get it centered. And the big advice I'll give everybody is, when it's close, good enough. You try to make it perfect, trust me, it'll get worse and it'll take you longer just to get it back where you had it. So if it's close enough, it'll still be in your eyepiece, so it just won't be perfectly centered. Before it gets dark, some magnify 6, 8, 10 times, and some of them, the ones on the bottom and the one up on the this one here is a 1 time, and as these 3 are 1 power. And this is probably 6 and 8 or 10 power. That's actually a 10 power right there, and that's an 8 power. Yep, it actually says it. All right, so I asked you before, what do you want to observe? Well, if you want to observe things like the planets, okay, Mars is up every night right now. If you wait up long enough or get up early enough in the morning, you'll see Saturn. Jupiter won't see right now because it's too close to the sun. But you can see the planets at different times. So if you like the planets, the moon's out lots of times. Double stars, that's Alberio. It's in Cygnus the Swan. It's the head of the swan. It's a blue and a gold star, really pretty. If you like that type of stuff, then consider a refractor. A refractor is this type of telescope, one like you might think of the one like Galileo used, okay, with a lens and a long tube, and then it focuses on the other side. If you want to observe deep sky things, like galaxies, which are dim and far away, nebula, which is like the gas, often the gas left from a star that died, where new stars form. Star clusters, which that's the star cluster, M13. That's in Hercules. It's actually about 500,000 ancient stars, all held together by gravity. And comets, if they're far away. Now, Hale-Bopp, if you remember Hale-Bopp, that was really close, and you didn't need a telescope. But some of the comets are far away, so you need a more powerful type scope. So then consider a reflector. Reflector means there's a mirror. So this is a reflector, and this is a reflector. Okay? And this is also a type of reflector, which we'll get into. It's a third type of scope. All right. If you want to see everything and don't want to buy 2 scopes, limited budget, consider a reflector. Because in general, this is just a general statement, you get more performance per dollar out of a reflector than out of a refractor. But it's not a strict rule. All right, so here's the basic optics of a refractor. So, I think this works. The image is formed by an objective lens. So we have a lens up front here, okay? And the lens is, you see the lens up there where the light comes in with the yellow arrow. Has a clear pathway. The light goes down that open tube with nothing in the way until it comes out at the diagonal or out the eyepiece. It has enclosed optics, which means the tube is sealed. No dust or moisture is going to get inside. It's sealed. But cheaper lenses may suffer from chromatic aberration, which means, so you know how red light is long wave and blue light short wave? Actually, they don't focus at the same place. So what happens, you get this shift of this funny looking color on the edges, kind of like a little bit like a rainbow halo. That's called chromatic aberration. And unless you have a better quality telescope, you might get some of that. But that's not a big deal. You just know the colors off a little bit. So here are some refractor options. I went on the website today. Prices are going up. I hate to say it, but there's shortages. Again, they're not buying a lot of stuff's made in China, and they're not buying it. One company's actually buying it, but storing it in a warehouse in China, not shipping it, because when it ships, it has to pay the tariff. So they'll see if the gamble works. We'll see. But anyway, so here's some refractor prices. So a 60 millimeter, this is an 80, but a 60 millimeter refractor, I don't see one in here, but it'd be like $100 to $350 depending on the quality, okay, with a simple mount, a mount similar to this mount where it moves up and down, moves side to side, okay. An 80 millimeter with an equatorial mount. So this is a German equatorial mount right here. Okay, and we'll talk more about the mount later. But this mount doesn't go up and down, right and left. It kind of goes in arcs. But it follows the sky as a star or a planet moves across the sky and rises and then sets. This mount will follow that same arc. Okay? So those are $230 to $500. And a better one, actually, I said this was an 80. This is 120. Yeah, this is 120. I was saying. That one is about 5 inches, and it's between $600 and $2,000 today. As I said, prices have gone up. Large apertures are very expensive. So in this style scope, the refractor, it gets very expensive. The refractor we have in the dome there, the 6-inch astrophysics, I think the price on a similar scope, if you bought it today, is $14,000. Okay? We bought it for $3,000 about 40 years ago, 40-some years ago. All right. Now, here's something that you might consider too. There are solar telescopes and filters. Now, I have to say this every time I talk about looking at the sun in the telescope. The sun can only be viewed safely through special filters and telescopes. You can't just put a regular telescope and look at the sun because you go blind instantly, okay? It's like holding a magnifying glass right at your eye and having you just burn your retina right out, okay? But the advantage of a solar telescope is there's no need to stay up late, or it doesn't even have to be crystal clear skies. You could see through light clouds and fog and light pollution. It's so bright, it's good. Now right now we're pretty much in solar maximum, so there's a lot of activity on the sun, a lot of sunspots, a lot of solar flares and prominences. We're getting aurora, okay, but that's an 11-year cycle. So in a while it's going to dim down to be not that much, but there is pretty much most of the time something on the sun, okay? So if you're interested, consider that. The PST stands for Personal Solar Telescope. It's like a little 40 millimeter telescope, but all it can look at is the sun, and that's fine. I have some friends that have some of those. And then we have the solar filters, which would be a glass or plastic or actually mylar filter. This is the lens cap, but it would just go over top of your telescope, and that works too. But that doesn't see, that will see sunspots. That will see the PST will see sunspots and flares and prominences because it uses like H-alpha light. This only sees what we call white light, where you'll see the sunspots. But it's still pretty cool. It makes it safe to look at things, okay? All right, so you have to consider the cost. Refractors cost more for a given size, so a 120 millimeter refractor costs a lot more than a 120 millimeter reflector. And astrophotography means a more expensive mount. It means you need something more like this, okay? Let me go back there because I want to show you that. I guess I go back to this one, right? So that's adding a camera to a telescope. Basically, you take the lens off the camera, you screw this tube on that has the same size, either 1.25" or 2". It fits right in your telescope. So the telescope becomes your lens, okay? It's just a simple adapter. It's that simple. And if you're doing something bright, you can get away without using a lot of tracking and mounts. But if you're looking at something dim, like a galaxy, you're going to need a mount that tracks. So here's the optics of a reflector. So light comes in the tube. All right, it comes in the tube and goes straight down the bottom. Now down here there's a curved mirror, often a parabolic mirror, okay? But not always that design, but most often. And then because of the design, it lets the light come back up the tube in a cone, which gets narrower and narrower and narrower until it hits what we call the secondary, which is a spot here that holds the mirror at a 45-degree angle. Light comes up and then shoots it out the eyepiece out the side. So light comes in the tube, goes down the mirror, back up to the secondary, and out the eyepiece, okay? It's a very nice design. It's called the Newtonian. Isaac Newton, he's the guy who invented it. So image is formed by a parabolic mirror, usually. There's an obstructed pathway. So the refractor had nothing blocking it. Light just came straight through all of it. This light has to go through and go past that mirror and a thing called the spider that holds that mirror in place. So it blocks it a little bit, cuts off some of the light, but usually it's so much bigger, you don't even notice it. It's an open pathway. So when I take the lens cap off, you stick your hand way in the tube. Dirt and dust and rain can all get in there, okay? So it's an open pathway as opposed to sealed. It has a folded pathway. Well, some of them do. In that it comes down and goes back up, okay? But there's no chromatic aberration, none of that false color. But it's a bit more difficult to point, because if I'm looking in here, and I'm looking at this way, it's a little harder. But if I have a finder scope on here, then I have no problem. So here's some refractor options. So this is simple Dobsonian. So there was a man who I knew, not well, but I knew, named John Dobson. He passed away probably about 7 years now. I think he was 94 years old. I used to see him every summer in Vermont, every July or August. He invented this thing we call Dobsonian. Although he hated the name Dobsonian, he wanted to call, he had his own name for it, but everybody just called it after him, a Dobsonian or a Dob, okay? But he lived out in California, and he was known for having sidewalk astronomy. He'd just bring his telescope out in the middle of light polluted California, wherever he was, plunk it down a street corner and look at something bright like a planet of the moon or a double star, and all these people would come and look through it, and they were just amazed at what they could see in that telescope. So he started teaching people how to grind the mirrors to make their own telescope. And that was great. They made great telescopes, but then they didn't have a mount. The mount was so expensive. You had to be a machinist and have a lot of skills to be able to make a mount. So he said, you know what, I'm going to make a simple mount. So I have one back here, actually. This 6-inch back here is a Dobsonian. Okay, thank you. Thank you.
Should we put it up on top so people can?
Yeah, on the chair or on here?
Oh, try the chair.
Okay. So, thank you. It's kind of like a cannon in that the base swivels and it moves up and down. It's that simple. And now how hard it is to use a scope? Got to take the lens cap off. Don't forget that. And where do you put it? I always tell people stick it under here. You know why? Because it's black and it's plastic. You put it on the ground, you're going to hear crunch. Okay? We have one that's made out of cardboard out there because of that. So put it under here. I kind of point it in the general direction. All right? And then I kind of look at this and get it in the finder scope right in the center. And if I have this aligned, I just focus this, and I'm looking at Jupiter or whatever it is I was pointed at, the moon. Okay, it's that simple to use. It's a great beginner's telescope. So John Dobson did this. You put this like that. So again, the same thing. Light comes down the tube, hits that curved mirror, comes back up in a cone, hits the secondary, and out the front. You might be able to see the secondary in there now. It's like a thing, and then there's a mirror on the end of it, okay? You come up and look at it after. You can even see your face, except it's a little distorted, it's bigger. But it's kind of cool. So these, one this size, used to be like $199. One like this was like $250. And then 8-inch, which is 8-inch diameter, was like $300. Not anymore. So today, a 6-inch, or a 4, that's a 4.5, I think, is $250 to $550. Okay, but it's still a good price. An 8 or 10-inch is $650 to $1,200, and you can go bigger. I've got literally 3 or 4 friends with 20-inch scopes, as big as our big one at Kopernik. Okay, George has one, and Rick and Mary Ann have one, and Patrick has an 18, and Keith has a. What's that? Keith has the 18. 18. Keith has the 18. Patrick has the 16 or 17. Yeah. Okay. But anyway, those are just guys in our club. So the other type of scope is called the Schmidt-Cassegrain, SCT, Schmidt-Cassegrain telescope, or Maksuto. It's a Russian name, similar in design. That's what this is. Okay. So it has what you call folded optics, which I'll show you. There's a diagram in the next slide, so I'll show you what that does. The image is formed by multiple mirrors and lenses. Okay, so light comes in the top, hits the mirror on the bottom, bounces back up. See the orange spot in the center there? There's a mirror on the back of that. And then it bounces right back down. And remember I told you about the mirror in the back? It's like a donut. It's got a hole in the center of it. So light comes in, hits the mirror, It puts the light back up, hits the back of that mirror, shoots it back down, and right out here. So this telescope is the equivalent of 2, 3 times as big. So it's compact in design, yet powerful, okay? That one there is really twice as big. So this, with the light focal length, would go down to there, then come back up. It means the telescope would really be about this big, okay? So those are some of the advantages of some of this stuff. The other thing it has a plate. This in the front here is a glass plate. They call it a corrector plate. And I recommend you never take that off, because if you take it off and you don't put it on exactly the same place, it has to get recalibrated. So if it gets a little dirty, clean the outside, don't worry about the inside. It's a closed system, no dust, no dirt, it's good. It's compact, we said. It's medium plus in price. It's between $1,000 and $4,000. Although this little, I don't have one here. This little one here is a Questar, 4.5, and it's like $4,000. This is a Meade, probably a 14-inch or 12-inch, and this is that's a 5-inch. But they have different style mounts. We'll talk about some of this later on. So the optics, light comes in the tube, goes down to that curved mirror. Like the other, it goes up in a cone, hits the back of that mirror, and straight down to the eyepiece, okay? So you could look straight through here and put the eyepiece right here, but the disadvantage of that is when you're looking at something really high, you're going to get down on your hands and knees to look up there, okay? When you have the diagonal, it changes to 45 degrees, so now you can look up here more comfortably. Okay? I didn't even talk about diagonals, but that's an interesting thing. So, mounts, different types of telescope mounts. They have different axes of rotation. So the equatorial mount, which I call the German equatorial mount, has one axis aligned with the Earth axis, okay? So that's why when it follows the planet, so if we put one of the big telescopes on an object, it tracks. That means all night long, it will track across the sky from sunrise to sunset, or as long as it's up in the sky. The other one, Alt-Az, means it goes up and down, right or left. So this is Alt-Az, up, down, right, left, as this one is too. Although this has the slow motion controls, which are nicer. But it goes up and down, and it goes right and left, okay? So, important thing about the mount, it could make or break a good telescope. So you want it to be solid and stable. You can have a really nice telescope on a really cheap, wiggly mount. And even though the scope is great, it's going to keep vibrating, and it's going to be so frustrating to you. Every time the wind blows, every time you touch it, it's going to do this. Spend a little more money, get a little better quality mount, one comparable to the scope that you have. The gizmos. All right, here's where you get your life preservers and your oars and your paddles and all that stuff. So there's a webcam or a CCD camera. Webcams are used often for planets. Today, when you take a picture of a planet, because planets are close and they're bright, we often use a webcam and to shoot for so many seconds and get thousands of frames. Now, I don't know if you ever noticed looking through a telescope, but because of the jet stream where we are, seeing goes in and out of focus. It's blurry, and all of a sudden it's sharp just for an instant, and then it's blurry again. And well, if you get 4,000 shots, the computer says, just give me the 10% best shots, and you put them together in the computer, you get a really crisp image. So webcam is nice. CCD camera also, coupled display. Smartphone adapters. This is a cool thing. So I see people all the time, and they do it pretty well actually, unlike me, is they get their smartphone and they put it on camera, and they put the lens on there, and they actually can get a picture of what I'm looking through the scope, and they do pretty well. I'm not steady enough. I can't do that. Okay? So for this, you would get this here, and you would, I didn't adjust this, but you would clamp this on there so it's clamped on there. Then you get your cell phone, you put it in here, and then you use, this has 3 different adjustments, up, down, well, X, Y, and Z, okay? And then you get your cell phone so it's perfectly aligned to the eyepiece, all right? And again, it's great, but you have to adjust it. If you use your cell phone all the time, it's great. This one's Kopernik's. You're welcome to use it, but it's not going to be adjusted. If my cell phone's not the same size as yours, you're going to have to adjust it, but that's fine. We have one now. We may end up with a second one. We'll see. Well, we have a second one. We just don't know where it is. We might end up with a third one. All right. Digital cameras. So I already showed you before a film of digital camera. Take the eyepiece off if it's a DSLR or an SLR and put that nose on there and use that. You can all, well, go-to telescopes. I didn't bring one out, did I? How bad. All right, this is a go-to. All right, this is a go-to. All right. So when I take this telescope out, first thing I do is I align, it has little marks on there to align it the right way. That's what you call home position. Okay? Then I have to get this and point it perfectly north as if I'm looking at, not north, but at Polaris. Okay? And I have to adjust it by moving this knob and this knob to move the mount, and then moving this knob and this knob that moves the altitude. If you're observing from the same place, up and down will never have to be moved. But if you go up north or down south, you're going to have to adjust it. But not a big deal. Okay? But you get that all perfectly done. All right, I'm ready to go. I get my hand paddle on, I turn it on. It says align. I say, okay, align. I hit enter. It says, okay, Vega. Okay, I said, okay. I hit enter. It goes, it moves with the motor. It has a motor. And I'm missing my other control. There it is. It moves to where it thinks Vega is, okay? All right. Well, I look in the finder. I don't see Vega. I look in the eyepiece first. I don't see it. I look in the finder. I don't see it. Then I look, and I say, oh, Vega's a little bit to the side. So I get my hand controller, and see these up and down, right, left arrows. I move it until I get it centered in here. Then I hit enter, and then it says, now center it in your eyepiece. So I go in the eyepiece, and if I'm lucky, I see it on the edge someplace, and I do the same thing. I center it, then I hit a line, and that means it knows Vega. Then it goes, all right, what's the next star I want? Alberio, okay? So I hit enter for Alberio. It gives me suggestions, which you can take or not. And then I do the same thing. And after I do it twice, theoretically it's aligned. When I do it 4 or 5 times. 5 is overkill, but 3 or 4 times is what you need. But then once I do that, the go-to feature works. I say, all right, I want to see a solar system object. I want to see Mars. I move this up and down till I get Mars, hit enter, and the scope automatically goes to Mars. Or I want to see a deep sky object. I want to see M13, that globular cluster. So I scroll, and I do M for Messier, then I go M, punch in 13, okay, and then I hit enter, and it automatically moves to M13. Or a star, if I want to see a specific star, like not Polaris, let's say Vega, okay, then I could do that and click on it. So that's go-to. The bad thing about go-to, if you don't take the time in the beginning to set it up, it's going to be very frustrating, and you're going to pay a lot of extra money for that feature, okay? So I don't recommend go-tos for beginners, okay? They're great, but this is, it's kind of hard. So it's like a learning curve. I'm not saying you shouldn't do it. And I'm not saying you wouldn't be able to learn how to do it and be able to do it. It's just that something like this is much simpler. Okay? EAA telescopes. All right. We're going to talk. I have a whole slide about those. So I'm going to skip over that for now. Okay? I added some new slides. So EAA, we'll talk about that. I don't want to get into it now. Filters. And I have a slide on filters too, and I'll talk more about that. So I'm just going to. Books and charts, star charts, yeah. Those are things you want. You know what a star chart is, right? Maybe not. This is a small one that came with this telescope. But it works. So you kind of, today's June, what time is it? So it's 9:30. So it's like 19, no. 21. Yeah, 21.5, 21 and a half, between 21 and 24. Today's the 13th, right? So what I did was I put the time, it's in 24-hour clock, so 21.5, or between 21 and 22, and I put this on the date for today, June. This is what I should see in the sky, okay? So there's north, so north is over there, and that's south, and this says that's west and that's east. Is that right? It's not. That's because I'm looking at a street map. I'm looking at a sky map. I got to hold it upside down. North, now east and west are right. Okay? And this one is a good one. You can use it all year long. Stars are always the same place. The planets move, but the stars are always in the same place. I have another one I'll show you in a few minutes. I don't want to get ahead of myself. Binocular eyepieces. So I think a lot of you will understand the science of why you see better with two eyes than you can with any one eye. So you can look the best you can see with one eye. You open the other eye, which isn't even as good as the other eye, you can see better. Well, how's that? Because two eyes are better than one, okay? And so some people buy an attachment, like a binocular, that you have to have two identical eyepieces. And it just goes in here. Take this out, put that attachment in here, put the two identical, and then it's just like having binoculars, and you can see even better. That's great for when you're looking by yourself. When you're looking with somebody else and you keep having to change this and focus in it, it's very frustrating. But it's kind of cool if you get serious to have. We have we call them bino viewers. We have a set of those here at Kopernik. And more. There's a whole bunch more that I couldn't fit on the slide. So a webcam can be the cheapest way to do astrophotography, but you'll need a laptop, okay, to store the data and to manipulate it. All right, filters and observing. So, you know what? I'm going to close this up because I'm going to trip over it. So filters will enhance your view of different objects, like a planet. So we have the basic filters, red, green, blue, and luminous, okay? So a different filter, looking at Mars, will show you different features. And then you put a green filter in, or an orange, or a blue, or whatever color they have. This is just a basic set of 4. They have big complex sets with 80 A's and 85 B's and all the 19 red and all the different things. But they'll enhance the thing. But they also have some that are good for planetary and emission nebulas. We talked about nebula being like a gaseous region. And they have star clusters like we saw M13 before, and galaxies, and even supernova remnants. They'll help you see those better. There are objects in the sky. I look through my telescope. I do not see. I know it's supposed to be there, but I don't see it. I put a filter in there, like an O3 filter or whatever, all of a sudden it pops out. Okay? So filters can really be helpful. We have a thing called the moon filter. At Kopernik, we have about 6 or 8 of them. And what they do is they dim the brightness of the moon. Because especially when your eyes are dark adapted and you're seeing those dim, fuzzy, galaxies and stuff, and all of a sudden you look at the moon, it's like looking in a bright light or in a bright room. So you put on this, it's like a green neutral density, like a eyeglass, but sunglass. You put that on and it cuts down the brightness, and it's nice. And they have some that are for light pollution, like in HGC and stuff. They're designed, if you live in an area where you have light pollution. I know guys who do astrophotography from their driveway, and they say the street light's right there, but they use these filters, and they can get some amazing work. So they're called narrow band filters. But again, everything's adding up, okay? But a basic set of filters and maybe a moon filter is not a bad thing. All right, here's what I was going to talk about. Put this down here. So we have this thing called an EAA, Electronically Assisted Astronomy. All right? It's a telescope. You don't really look through it. There are some that you can. But this is one. Kopernik has 2. We have the normal size one and the baby little brother. Comes in a nice little case. Scope's right here. Little tripod. Okay? All in one in this one little case. That sounds pretty interesting, but let me go into some more detail. I don't look through an eyepiece. I use Wi-Fi and I look at it through my cell phone. And you know what? 4, 5, 10 people, it depends on the scope, can all look at it at the same time. You can all save the image on your phone. Okay? This takes an image. All right, let me get back. It does a cell phone or a tablet. It's automatic. You turn it on, the GPS in there knows where it is. It doesn't have to find this star and that star and that star and figure it out. It knows exactly by the date and the time. I have to put the accurate date and time in, by the way. It knows the date, the time, your location, and it knows what stuff is in the sky. And it finds it. That's pretty cool. Automatically. It does astrophotography. That means it takes pictures. It takes a picture. Usually we set it for what? 1 minute exposure? But it can do 2 or 3 minutes at a time, depending on how clear the sky is, okay? How many satellites you're going to get going through the image. But it's very good, by the way. But it's not as good if you have hours of time and like a scope like ours is like $270,000. If you have something like that, you're not going to touch. This isn't going to touch that. But you know what? For $400 or $500, this is really good. How much does it cost? The cheapest one that I found is this one. It was like $199, or maybe $229. It might be $229. This one here, the little one in that little case over here, it's white. It's just like this one. It's $299, right, Jenny? $299, I think. And this one is the one we have. That's now $499. When we first bought it at Kopernik, we paid $399, but it caught on real fast, and the price went up $100. And then this one of our guys has a couple of these too. Some of these are better. Some of them are similar to this. Some of them are similar to this. Some of them are even better, but they're different prices. And they have real expensive ones, like this one, the EV scope. That's like $4,000. So these are some examples that my friend Keith Wertman, he's a KAS member. He took them last week. You know those cloudy, rainy nights we had? He did this. So this is That's M16, the Eagle Nebula, with the C-star F50. That was 17 minutes of exposure. So 17 pictures stacked together. Every picture, you first get the picture, you're not going to see much. You're going to get the second one, it's going to stack it, still don't see much. After about 5, oh, I can see it. Then after 10, wow, it's getting better. He did 17 and ended up with that. Okay? This is another one here. This is M17. That's the Swan, sometimes called the Omega Nebula. And that was 16 minutes of exposure. And this is M51, the Whirlpool Nebula. And that's 184 minutes. So that's over 3 hours. Okay? But he captured, that's a galaxy. These are bright nebula. This is a dim galaxy. That galaxy is, you know, the Big Dipper, the handle? It's like near the end of the handle below it. Okay, right in there. I've seen it in my telescopes from a dark area, but not like this. Okay, I could see like the bright center and a little bit sometimes of the arms, but not much. And then there's, oh, C-star comes with a filter that you snap in. Comes with the charger and everything, but it comes with a solar filter. Okay, you put it on, and it takes pictures of the sun. Now, the sun and the moon are tough for the C-star to find. Why? So when this is first turned on, it does a thing called plate solving. It takes a picture of the stars, and it compares that picture to a database of a star map. And it keeps on doing that until he says, all right, I got it perfectly aligned. I'm good. When the sun is there, or the moon, it's just like one thing. And it guesses at where it is, but it's not. So that may take longer. You may have to help it a little bit. But you can see what it can do. This is one he blew up a little bit. 4 times, okay? But see the sunspots on it? And that's a comet. That's not a Hale-Bopp comet. It's a comet that's you have to see in a telescope. But he did that, and that's 2 minutes. Okay? And this is the Veil Nebula. It's a remnant of a supernova called the Veil Nebula. And he did 21 minutes, but you see the colors in it in that bright star. And this is called the Pelican. Where is it? Well, I'll tell you, it's the Pelican. So you see the head of the Pelican right there? Mm-hmm. And right next to it, there's the North American Nebula. They're like close together. But he did that in 54, so almost an hour. So you see what this type of thing can do. And for $500, I can't buy the scope or the mount or the software or the lenses or all the stuff. And that just does it, boom. Yes?
No, I'll ask it later.
Okay. All right. Yeah, sure. So get familiar with the sky as best you can. So, well, I'll do this way. Constellations, we know there are 13 basic constellations, right? Well, no, 13 zodiac constellations, right? There are lots of constellations. Try to get to know them in the winter time, like Orion and Gemini and Castor and the Gemini twins and Leo, and and then in the summer Sagittarius and Scorpius, and the summer ones. And some of them are out all the time. Okay, like the Big Dipper and things like that. So try to learn those and where they are to one to another. North Star. So where's the Big Dipper? Let me find the Big Dipper. There it is. See the handle and the bowl? And that's Ursa Major, the Great Bear. So if you take the bowl of the front 2 stars in the bowl and point them up, they say 2.5 times. It points at Polaris, the North Star. And that's the tail of the Little Dipper. Okay? The thing about the North Star, Polaris, it's always in the same place. Every day of the year, every hour of the day, Polaris is in that same spot. Okay? I go outside of my house, out the kitchen door, I look to the right above the big maple tree, and right above the maple tree, Polaris is there all the time. Anytime it's dark, I can see Polaris right there. Why is that? Well, you know how the Earth rotates on its axis in 24 hours for a day? The pole points right at Polaris. So as the Earth is rotating, all the stars, it goes this way, all the stars look like they're going around that one point that's staying still. Okay? but really the stars aren't really moving. It's really the Earth rotating in 24 hours. Okay? That's why Polaris was used by with ships to navigate. That's why the slaves use it to find north, to find freedom, you know, because they didn't have GPS, so they use that. So anyway, the North Star is pretty cool. The ecliptic. So this is a line that the sun takes across the sky every day, where it rises in the east and sets in the west. That ecliptic path is like an arc, and from Kopernik, it starts out in the east and goes up like that and comes down to the west. So anytime you see looking for so not just the sun, but all the planets and the moon are in that same arc. So anytime you're looking for a planet or the moon, you'll find the sun pretty easily. Just look in that ecliptic zone, because it's always the same, okay? And you'll find that. Star maps. I showed you a star chart. I'll show you a star map. Here's one here. Oh, wait. It has their coordinates, right ascension, and declination. We don't use that too much anymore. We've got better things. But this skymaps.com seems strange, but I keep one in my pocket every month. This is what, June? Oh, making a liar of myself. All right. I know I have it. I just don't. This one might be May's. Oh, this is June. I just had it in the wrong place. That's a star map for this month. Okay? It has different events that are going on by the day. Like today's the 13th. Well, the 10th was the moon was near Antares. Full moon was on the 11th. On the 17th, talking about Mars and last quarter and all the different things for that month on that year. On the back has all these cool things you can see, naked eye, with binoculars, and with the telescope. So I'm looking for Orion. I'm not going to find it on here because Orion's set already. It's out in the daytime, like 4 o'clock in the afternoon. It's a winter constellation. But this is pretty cool. And the cool thing about it is you're allowed to get one of these every month for free. Go to that website. I have that here, don't I? Go to skymaps.com, and then you click on downloads. I did click, didn't I? Oh. All right. And then if I hit download this, it gives me the, is this working, Jenny? Yeah, I'm just trying to show them, but what it would do, it usually comes up really quick. And it comes up with the 2 pages of this, then just print it, okay? It's not a big deal. But I can't do July's until July 1st. I could buy them ahead of time, but they won't give it to you for free until that month. But every month, it's pretty cool to have that. All right. Thank you. All right, so we did a bunch of this stuff already. All right. So, using your new telescope, if you have a manual, at least look through it, okay? Get a friend to help you. Someone who, even if they don't know anything about it, they'll help you figure it out. Join an Astro Society. You're welcome to join us, the KS. Right now we have I think 6 of us here, 7. Count me. Take an astronomy course, if you like. Visit an observatory, like Kopernik. Hey, you're here. Simple plan for observing. Try to do it when the skies are clear. If it's a rainy, cloudy night, don't bother. Decide on the location. If you can get to a dark sky darker than where you live, that's a good thing. Bring a friend so you're not alone. It's a little safer. Have a red flashlight. Why red? Because red will preserve your night vision. The white light will kind of mess you up. Set up in a line during daylight, hopefully. Dress for the weather. So believe it or not, I keep a sweatshirt in my car even in the summertime, except for when my kids used to be there. Then my sweatshirts would always disappear. But they're grown up now, so that doesn't happen anymore. Because at night, it cools down. And even though you're wearing shorts and short sleeves, at night, you want to put that sweatshirt on most of the time. And stay safe and enjoy the night sky. Seek help and advice. Again, read about their magazines, their articles. Watch YouTube. A lot of astronomy is learned today by YouTube. There are all these guys with stuff on YouTube. Ask a friend. There's smartphone apps. You can get an app that lets you do the night sky, and you pick it up, and as you move the smartphone, it shows you what you're looking at in the sky. Join a club. Again, the KS, the Kopernik Astronomical Society. This logo was designed by Joe Bergeron. He's a member of the KS. We meet on the first Wednesday at 7 p.m. in person here at Kopernik or over Zoom. So if you're interested, I'll give you the link to come and join us. A simple option, just get binoculars and a tripod, a nice lounge chair, and just hop around from place to place. Okay? And, all right, so just a quick raise of hands. Anyone interested, if we had we're thinking about this. Anyone here interested in a class learning how to use the electronic telescope? Anyone interested in doing that? Or learning basic astronomy class here? Or learning astrophotography and image processing? Okay, so I have 2 sign-out sheets. If you're interested, now this is nothing that's been decided yet, but if we get people interested, we'll try to do something. Probably the astrophotography class won't be till like the winter time, because right now the nights are so, it doesn't get dark till 9, 10 o'clock. So if you're interested, if you give me your name, email, and phone number, and then check the box of the one or ones that you're interested in, that'd be great. All right, what questions can I answer now?
I was just wondering,
Hold on,
when?
let me get the microphone so the people on the live stream can hear it. And let's see, what do we got? We got, yes, we do.
When we were talking about the sea star, okay, and 184 pictures in order to get that, what kind of battery does that require if you're doing something for 4 or 5 hours?
So
okay?
that has a built-in battery that will last 4 to 6 hours. It has a built-in dew heater. If the dew heater's on, it won't last, it only lasts like 4 hours. If you don't have the dew heater on, it probably lasts 6. But you know the little battery packs you have? You just get that and plug it in, and you have as much as you need.
Okay,
Okay?
all right. Thank you.
Any other questions here? And let me just check the YouTube. Are we? I don't know that. Okay, YouTube. Okay, let me bringing it up. Beginning telescopes. All right. Is it the one about setting up the DSLR, or no? Okay, so there's a question. It says, I have an inexpensive Celestron StarSense Explorer DX 130AZ reflector telescope, like one of those. It's limited for its reach across the sky. Do I need to calibrate it? I wish for a better scope. Any suggestions? So it's a
Celestron.
It's a Celestron.
6-inch?
Well, it's a 130 AZ. So I'm assuming it's 130
Okay, so it's
millimeter.
a little bigger than 5.
Yeah. It's
Actually,
limited for its reach across the sky. I'm not totally certain what that.
that's, I don't know what he means by that, but that scope is capable. It's like a 6-inch scope, right? 130 millimeter. 5.5. Okay. Thank you. 21, right, 127 is 5 inch, because Patrick and George and Keith have 127s. So if he can get it to track, that would be great. Or if he uses a bright object, okay, like a planet, where it doesn't need to track, that would work too.
Yeah, I don't know for sure, but the Star Sense Explorer, I think it is a tracking scope.
Yes, it is.
So,
It's
yeah.
like the one, the orange one.
Oh, okay, right, there you go. All right. All right, any other questions here? Our friend Lindsay, by the way, is watching from Adelaide, Australia, so she says hello. Well, if there aren't any other questions, Eric, thank you once again for really taking us deep into all that astronomy can offer and how to get into it. Especially for those people who maybe are here for the first time or haven't been here in a while, we'll be happy to give you a tour of the scopes we do have, and we can show you some of the images that we've taken with our big 20-inch scope. So next week, this is astronomy month here. Next week, Jenny is actually going to be doing a talk on the summer skies. So now that we've sort of gotten you thinking about what scopes might be might interest you, Jenny will now talk about what can we actually see this summer. Like we're in a bit of a planet drought, if you will, in that right now Mars seems to be the only one that we can see. However, there's a lot more than just planets to be able to see through the scopes, and Jenny will talk about that as well. Then the following week will be the Great Telescope Dust-Off. So again, if you've got a scope that's sitting in your basement, or if you end up buying a scope, between now and then, bring it on up, and we'll help you get it set up, and hopefully we'll have a clear night. I think this is the 29th weekend in a row that we've had rain on the on Fridays and Saturdays. So,
All right, so let me finish off with a pitch here. Sometimes we get scopes here that we try to sell, and we use that money. It goes into a thing called the telescope fund, which we use to buy more telescopes and stuff. This is a Barlow, by the way, that goes in the eyepiece, and the other eyepiece goes in here. This is a finder. This scope is brand new. It hasn't been used. I was going to put it together, but probably better leaving it like this. But we're selling this for $150. It has the manual, has the star wheel, the tripod, the scope, a CD, and it has 4 eyepieces, not just one. Now these are those little smaller eyepieces, okay? These are the .96, but it has 4 of them. A real high power one, which you'd only ever use if you're looking at the moon, okay, or maybe a great night looking at one of the planets. But it has a 9 and a 12.5, and I think the one I had was a 20. So it has a nice variety of eyepieces. So if anyone's interested, we have this one, and we have one out on the counter here out there, right, that we're selling as well. So, all right.
and it has a carrying case. So
It does.
that's another thing you'll find out is that when you start, bringing stuff around, okay, you got the scope, okay, now where are my eyepieces, where are my dew shield, where, where's the tripod? It's all in one shot here.
So my setup like that has a case for the tripod and a case for the tube, and then I have a case for like the extra stuff, that all comes apart. So, yeah, having it all together is nice. Because if you forget one part, it's not going to work. Okay, it's like only having 3 wheels on a car. Doesn't work.
All right, well, thanks again. Again, appreciate y'all being up here today. Thanks, Art. What? Oh, one more question. I'm sorry.
On the scopes, I think you called that the refractor?
The
No, yeah,
refractor is the one with the lens. The reflector is the one with the mirror.
Okay, that's an open tube.
Right.
When you're using it.
Yes.
How do you clean it? How do you keep it away from dust.
So the way you clean it is you don't let it get dirty. Keep the lens cap on.
Yeah,
and
but
then-
if you're using it,
That's not going to make that much difference.
Okay.
No. Actually, you can have years of dirt and dust on your mirror, and you won't really notice it. You'll notice it after you clean it. You go, whoa, that's a lot better. But you really won't notice it. Okay? You will notice it, but not a lot.
One thing I will actually talk about, whenever we have school groups come up here, we always take them into the into the domes, and we'll again, they're up here during the day, so we usually end up, if like yesterday actually, we put a solar filter on one of our scopes so that they could safely look at the sun. And so unless, like if you buy a telescope, you can never ever use your scope unless you have a solar filter specifically designed for it. Did you mention it? Yeah, so in this case, right. So this has a Mylar filter on it. I think it's worth repeating.
Oh, please.
But also one of the things that we do is I got to talk to them about like when we had last year, we had that solar eclipse that nobody around here really saw, and a bunch of us got those solar eclipse glasses, right? Well, you can't use those solar eclipse glasses with your telescope or your binoculars, because actually when we go out to the domes, I can actually show you that. I actually as we were preparing for the school groups that we were doing, talking about the eclipse last year, I actually set up a pair of binoculars looking at the sun. I put my hand in front of the front of the binoculars. I put the eclipse glasses behind where the eyepieces were. I just went 1001 and then covered it back up again. And I can show you those glasses. They have 2 pinholes where the sun burned right straight through that film in under a second. So don't do that.
Yes. So the filter has to be before the lens.
Right.
And it has to be the right type. Okay.
Although there are filters that
Yeah, in the diagonal.
we have a filter that actually is part of the diagonal
It's
down
called
here.
the Herschel wedge.
Right. But again, that's really expensive, and even that that solar filter. After I have a group of students come by there, I move the dome so that it's no longer heating up that because basically the Herschel wedge takes like 95% of the light away, and it's really converting it into heat.
Yeah.
And we don't want that.
Because the scope is tracking with the sun. So even though no kids are there, the scope's still pointed at the sun. So what we do is we move the dome to the west, to the east of the sun.
Right.
So as it's in the shade, it's looking at the dome.
So even though the scope is tracking, it's tracking away from the opening. Anyway, we could go on forever. And so anyway, would love to give you a tour of the scopes if you'd like. Otherwise, hope to see you up here soon. Thanks again, Art.